Hi, class. Welcome to lesson 9.2, length of line segments. And again, we just started unit 9, and it is about the coordinate plane. We touched upon lengths of line segments on our last video in our last assignment. So let's continue on looking at lengths of line segments, and there's a lot of problem solving involved with this one. So let's go ahead and get started. Part 1, the first part, says plot each pair of points on the coordinate plane below, connect the points to form a line segment, and find its length. So it's asking us to do several things. Plot the points and connect them, and then tell how far apart they are. Okay, and it says, and we need to draw our X and Y axis. So let's go ahead and draw our X and Y axis. We'll put the X axis approximately in the middle. And we'll put our Y axis about in the middle as well. Okay, so here's our X and Y axis. Now we need to plot A and B, and then we'll connect them, and it will make a line segment, and we'll see how far it is. And then we'll connect E and F. We will plot these 2 points, connect them, see how far the line segment is. And then the same thing with the other points. Okay, so A is at 6, 2. We're going to go over 6 and up 2. So over 6, 1, 2, 3, 4, 5, 6, up 2. So this is A. B is at 6 and negative 3. So we're going to go over 6 and down 3. So we're going over 6, and now we're going down 3. 1, 2, 3. So this is point B. And then it asks us to connect these, and this makes a line segment. Okay, so now we need to tell what is the length of line segment AB. So each of these is 1 unit. So we are going to just count our units. 1, 2, 3, 4, 5. So the length of line segment AB is 5 units. All right, let's look at EF and do the same thing. Point E is negative 5 and 3. So we're going to go backwards 5, up 3. So start at the origin, back 5. 1, 2, 3, 4, 5, up 3. 1, 2, 3. All right, this is point E. Point F is at 1, 3. So we're going to go over 1, up 3. So go over 1 and up 3. And this is F. And I connect them, and it's going to make a horizontal line segment. And now we need to tell the length of line segment EF. And we just count the units. 1, 2, 3, 4, 5, 6. So this one is 6 units long. Okay, class, I want you to do the same thing for line segment CD, GH, MN, and JK. Tell how long they are. All right, let's look at the next one. The next one, the directions say find the coordinates. So this is lots of words, but we're just going to take it one step at a time. Rectangle ABCD is plotted on a coordinate plane. The coordinates of point A are 1 and negative 1. The coordinates of point D are 1 and 2. Each unit on the coordinate plane represents 1 centimeter, and the perimeter of rectangle ABCD is 18 centimeters. Find the coordinates of point B and C given these conditions. A, point B and C are to the right of points A and D, and B, point B and C are to the left of points B and C. Okay, so lots of words. First thing we need to do though is let's draw our X and Y axis. So we'll make this about a little in the center, towards the center. There's our X axis and our Y axis. Okay. It is a rectangle called ABCD. And one thing you need to realize about rectangles, the names of rectangles. A connects to B connects to C connects to D, and then D goes back to A. So the order matters when we are naming it. So rectangle ABCD is plotted on a coordinate plane. And then they give us the coordinates of A and D. So let's go ahead and plot those. A is at 1 and -1. We're going to go over 1, down 1. So we'll go over 1, down 1, plot it, and this is called A. D is at 1 and 2, over 1, up 2, over 1, up 2, 1, 2. And that is D. Okay, points B and C. So we are making a rectangle. Now, what do we know about a rectangle? We know that opposite sides are the same length. So the top and bottom are the same length. The two sides are the same length, left and right, same length. Okay, I know that this is part of it. Okay. We know that we need to make a rectangle. Okay, so A says point B and C are to the right. So we're going to put points B and C over here someplace so that the perimeter is 18. Well, if I can figure out how long this one is, how long like the top is, then I already know the side is the same as this and the bottom will be the same as the top. So if I find half the perimeter, that will help me. If the distance all the way around is 18, if perimeter all the way around is 18, halfway around would be half of 18. And what is half of 18? Yes, 9. Okay, so we already have 1, 2, 3. We have 3 units this way. And I need to go a number of units this way, so I have 9 units. So that would be half of our rectangle would be 9 units, and then we can connect the rest. So I've already gone 3. How many more do I need to go for 9? That's right, 6 units. 3 units plus 6 units. That's 9 units. 3. All right, so let's go 6 units this way. 1, 2, 3, 4, 5, 6. So I know this is a point. And then the other point would just be to make a rectangle right here. Okay, so let's connect those and we'll double check to make sure, and then we'll label them. I didn't label them right away because remember they have to go in that order. Okay, so here is a rectangle. It needs to have a perimeter of 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it went 9 this way, plus 3 more would be 12, plus 6 more would be 18. Bingo. Okay, the last thing, A connects to B, B connects to C. So I have to go from A to B. So B, this has to be point B, B to C, C is here, and then D. Okay, so the points B and C are to the right in this instance. So what are the coordinates? Well, I'm going to just move this over here. Point B is right here. So we went over 1, 2, 3, 4, 5, 6, 7, and down 1. So it's 7 and -1. C, we're going to go over 7 again, but up 2. So it's 7 and 2. So those are the coordinates of B and C. Now that's for situation A. Now situation B says, what if B and C are to the left of A and D? Okay, the same situation, only our rectangle is over here. It's still 18 units for the perimeter. The perimeter is still 18 centimeters. So we've gone up 3. So I have to go how many over here to equal 9? Do you remember how many units we have to go this way? Instead of going 6 units this way, we're going to go 6 units the opposite way. 1, 2, 3, 4, 5, 6. So, and then the other, to make the rectangle, we would line it up like this. Okay, so let's connect them. All right, A connects to B. So if I'm going this way, I'm going to do A to B, B to C, C to D, and then D back. Okay, so A was if C and B are over here. B asks, what if it's on the other side? What are the coordinates now of B and C? So the coordinates of B, we're going to go start at the origin. We're going to go back 1, 2, 3, 4, 5. Back 5, down 1. So backwards, back 5 would be -5, down 1 would be -1. So in this instance, B is at -5, -1. C, we're going to go back 5, but instead of going down, we're going up 2. So C would be -5 and 2. All right, so 7 I wanted to do together. So that 8 is kind of the same situation, only you're drawing a square, and they give you two different situations. So it's working the same way, but with a square instead. But let's go ahead and draw our axes, and we'll put them close to the center for this. X-axis about here, y-axis about here. All right, and you do 8. 9, we're going to strategically put our x-axis down lower. So what I want you to do is, see how low I drew it? I drew it so that there's only 2 units at the bottom and this. Let's do 9 together. 9 says triangle ABC. Okay, so we're dealing with a triangle is plotted on the coordinate plane. The coordinates of A are -2 and 2. The coordinates of B are 6 and 2. And the coordinates of point C are 6 and 5. What type of triangle is triangle ABC? And then they say figure ABCD is a rectangle. Plot point D on the coordinate plane and give its coordinates. Okay, lots of stuff to do here. The first thing we need to do is plot triangle ABC. A is at -2, 2. So back 2, up 2. So we're going back 2 and up 2. That is A. B is at 6 and 2. So I'm going to go forward 6, up 2. Start at the origin, forward 6, 1, 2, 3, 4, 5, 6, up 2. It's going to be B. And C is at 6 and 5. So we're going to go forward 6, up 5. So forward 6, up 5. 1, 2, 3, 4, 5. C. All right, and let's connect them. A goes to B. B goes to C. And then C goes back to A. Okay. Now this says, what type of triangle is triangle ABC? Okay, there are 2 ways that we can classify triangles. One is by side length and one is by angle measure. Now the side length, in this instance, we have a small length, a medium length, and a large length, and that would be scalene. So we've got scalene by side length. We'll just write down both classifications. The other classification is by angle. And there are 3 types of triangles that are classified by angle. One is acute. An acute triangle has all acute angles inside of it. Well, this angle here is acute, and this angle here is acute, but this angle right here, do you know what this angle is called? You remember? This has a right angle, and any triangle that has a right angle is called a right triangle. And to be quite honest, I think for this situation, right is what they were looking for, but it's also scaling. Okay, so we have a right triangle, a scaling triangle. Then it says figure ABCD is a rectangle. Plot point D on the coordinate plane and give its coordinates. So I need to put point D so that it connects to C and it connects to A and makes a rectangle. So where would I put point D, excuse me. Well, if I want a rectangle, I would have to move it out here. There's D. Okay. And so now this is a rectangle. A to B, B to C, C to D, and then D back to A. All right, now I have a rectangle. What are the coordinates of D? So starting here, am I going to go forward or backward? I'm going backwards. How many? Going back 2. So my first coordinate is back 2. Then I'm going up. 1, 2, 3, 4, 5. So -2 and 5. All right. Let's okay, page 23. In the diagram, figure PQRSTU. It's a big, unusual figure. Represents a field. The side length of each grid square is 5 feet. Use the diagram to answer questions 10 through 13. So this represents a field. The field is kind of in this L shape. It's got this little skinny part here and this fatter part here. Notice that the grid is counting by 5s. It's not counting by 1s. So each of these is 5 feet. And then we're going to use this to answer questions. All right, number 10 says give the coordinates of points P, Q, R, S, T, and U. So I'm going to get you started. You just list them and list what the coordinates are. So let's look at P. P, here's our origin. Now we're going to go back, but we're back to -20. And then when we go up, it goes up by 10. So the coordinates are -20 and up 10, 10, -20 and 10. Let's look at Q. Q is over here. Q, we're going from the origin, we're going forward. How many? It's 5 feet. Each unit is 5 feet. We got a 5 and then up to 10. So it's 5 and 10. So sometimes when you have a coordinate grid, the numbering on your X and Y axis may not be by 1s. In this case, it's by 5s, but we just take the numbers that are there, okay? So if it's counting by 5s, we don't count 1, 2, 3, 4. We're counting 5 feet. Each of these is 5 feet. So you do the same thing for R, S, T, and U. 11, I'm going to get you started. James and Rita build a picket fence around the field. They leave a 5-foot opening for the gate. What is the total length of the fence? Okay, so the fence is going to go all the way around the field, and they're going to have, but they need to leave a little 5-foot opening for the gate. So how much fence do they need? They need all of it around except for 5 feet. And one thing I want to caution you about when you're counting how many feet, each of these is 5 feet. So PQ, we're going to count by 5s. 5, 10, 15, 20, 25. So this is 25 feet. Okay. Q to R. How many feet is that? Q. 5, 10, 15, 20, 25. That's also 25 feet. And then R to S. How many feet? 5, 10, 15, 20. This is 20 feet. So you do the same thing, figure out how many feet, and then you figure out the total, but you need to take out 5 feet because we're going to leave 5 feet for the gate. All right, so you finish that one. 12, gate VW, that tells me we're going to call it VW, 2 new points, lies on RS and is 10 feet away from point S. Give the coordinates of V and W. I'm going to write V and W. All right, let's figure out what this means. It lies on RS. RS. Okay, so here's RS. I may need to erase that and move that 20 feet. I'm just going to put it up here. Okay, so our VW lies on RS and is 10 feet away from point S. So here's S. Oh, there's VW. They have it listed for us. Okay, it is 10 feet away from point S, 5, 10. There's V. Here's W. Okay, so here's our gate. Right there. All right, so the question is, what is point V and what is point W? So you tell me the coordinates for that. And then the last thing is find the area of the field. Find the area. Area is length times width. And what I would do to find the area of this is an unusual shape. But I see two rectangles. And I can draw a line kind of right here. And then I've got this rectangle. So if I find the length of this rectangle and the width, and then multiply it, that will tell me the area of this part. And then I've got this little rectangle hanging on here. So find the length and width and multiply and find the area of this part. When you have the area of this and the area of this, add them together and you will have the area of the L shape. All right, last page in this is page 24. It says, in the diagram, figure ABC represents a playground. The side length of each grid square is 4 yards. All right, and then we can see that in the numbering. Each of these is 4 yards. Use the diagram to answer questions 14 through 17. All right, we have this triangular shaped playground. And 14 says, give the coordinates of points ABC. I think you can probably, hopefully do that very easily at this point. So write the coordinates of ABC. 15 I want to do together because this one's slightly tricky. It says there is a square sandbox called DEFG. In the playground, point D is 20 yards from point A. DE is 8 yards in length. EF is also 8 yards in length and is parallel to AC. Okay, so let's think about this. You've got this square playground and it's DEFG. So DEFG. And we know that D is 20 yards from A, DE, this is 8 yards, EF is 8 yards, and EF is parallel to AC. So that means EF parallel means EF needs to go in this direction. All right, so I need to make a playground. D needs to be 20 yards away from A. So there's 2 ways I can do this. I can make, let's look at both. D is 20 yards away. 4, 8, 12, 16, 20. So that would put, I'm going to kind of lightly write that, D here, and it's 8 yards, so this is 4, 8, E would be here, and then F, or E to F, F, 4, 8, F, and then G would be here, okay? It may be here, okay? Or if we did 20 yards away, or 20 yards away here, D is 20 yards away. If we went this direction, D, or 4, 8, 12, 16, 20, D would be here, E would be here, F would be here. Uh-oh, do you see the problem? If this is my square playground, my square sandbox, excuse me, it would be outside the playground. So I know DEFG is not here. So this is our I'm going to go ahead and write this a little bit darker. Plot and label points DEFG. So D is here, E is here, F is here, and G would be here. And there is our square sandbox. It's 2 units. Well, it's actually 8. 8 by 8. Okay, So there's our square sandbox. Okay, if BC, I'm going to get you started on 16. If B, oh, last thing. We plotted and labeled, oh, that's it. Okay. If BC is approximately 49 yards, what is the perimeter of the playground? Perimeter is the distance around, okay? The perimeter would be the distance around. They're telling us that BC, this one is 49 yards. We do have enough information to figure out how many yards it is across and how many yards it is down. So you need to figure out how many yards from here to here, how many yards from A to C, and then add 49 to it, and you will have the whole perimeter. All right, 17, I'm going to actually ask you to omit that. Don't worry about 17. All right, class. Well, this was a problem that had a lot of side lengths. We learned that our grid does not necessarily have to count by ones. It can count by fours, fives, anything. And good luck. If you have questions, call me, contact me, and I will talk to you later. Have a great one.